Welcome back to Technician's Toolbox. This video will give you an overview of gasoline direct injection. Gasoline direct injection, or GDI, has been in use since 1925. General Motors introduced direct fuel injection in the 2007 model year. Spark ignition direct injection is used on the 2007 Saturn Sky and Pontiac Solstice GXP and later on the Buick Enclave 3600 engine. Certain Lexus and Infiniti models also use GDI. The 2008 Lexus LS600HL uses a combination of port injection and direct injection and is fitted with both injectors. The GDI system as used by GM differs from standard fuel injection systems in that the fuel is injected at a much higher pressure, up to 2200 psi, directly into the combustion chamber or cylinder instead of the intake manifold. As a result, less fuel is required to produce the equivalent horsepower, especially at normal cruising speeds when compared to a conventional port injection combustion system. Fuel injectors are mounted in the cylinder head beneath the intake ports and spray fuel directly into the combustion chamber. Direct injection requires high fuel pressure due to the fuel injector's location in the combustion chamber. Fuel pressure must be higher than the compression pressure, requiring a high-pressure fuel pump. The high-pressure fuel pump is a mechanical, one-cylinder design driven by an additional three-lobe cam on the camshaft. The high-pressure pump is capable of developing fuel pressures of 2200 psi and contains an integrated pressure relief valve. The fuel rail pressure regulator is incorporated into the high-pressure fuel pump and is a magnetic actuator which controls the inlet valve of the high-pressure pump. Using output drivers, the ECM provides battery voltage to the actuator high circuit and ground on the actuator low circuit. When both drivers are deactivated, the inlet valve is being held open by spring pressure, which will default the high pressure pump to low pressure mode. When activated, the fuel rail pressure regulator is pulse width modulated on the low side circuit to achieve the fuel pressure commanded by the ECM. 3 regulator control pulses occur every 720 degrees of crankshaft rotation. The solenoid is duty cycle at about 4 kHz. Fuel rail pressure sensor is mounted to the fuel rail and constructed of stainless steel. The 3-wire sensor sends a variable signal to the ECM. When fuel rail pressure is high, the signal is high. When fuel rail pressure is low, the signal is low. The fuel injectors also require more electrical power due to the high fuel pressure. ECM supplies a separate high voltage supply circuit and a driver circuit for each fuel injector. Will then operate at 65 volts. This is accomplished because the ECM contains a DC to DC converter which charges a capacitor to 65 volts. During boost phase, the capacitor is discharged through the injector, allowing for the initial injector opening. After that, the injector is held open by modulating the system voltage, which is 12 volts, while the capacitor is being recharged for the next firing event. As the vehicle is driven under varying operating conditions, the amount of fuel required for efficient operation also varies. In a typical port fuel injection system, the ECM responds by increasing the injector pulse width when more fuel is needed and decreasing it under low fuel demand conditions. The GDI system operates differently in that the amount of fuel injected is controlled via fuel pressure and not pulse width, much like a common rail diesel system. This is a 2008 Cadillac STS 3.6 liter at wide open throttle, 6,300 RPMs. The injector pulse width is 4.2 milliseconds and the fuel pressure is 1,731 psi. Cooling effect of the injected fuel and the more evenly dispersed mixture allows for more aggressive ignition timing curves. Emission levels can also be more accurately controlled with this system. Ultra lean burn mode is used for light load running conditions at constant or reduced road speeds where no acceleration is required. The fuel is not injected at the intake stroke, but rather at the later stages of compression stroke, so that smaller amount of air-fuel mixture is optimally placed near the spark plug. This stratified charge is surrounded mostly by air, which keeps the fuel away from the cylinder walls for lowest emissions. The combustion takes place in a donut-shaped cavity on the piston surface. This technique enables the use of ultra-lean mixtures impossible with carburetors or conventional fuel injection. Stoichiometric mode is used for moderate load conditions. Fuel is injected during the intake stroke, creating a homogeneous fuel-air mixture in the cylinder. From the stoichiometric ratio, an optimum burn results in a clean exhaust emission, further cleaned by the catalytic converter. Full power mode is used for rapid acceleration and heavy loads, as when climbing a hill. The air-fuel mixture is homogeneous and the ratio is slightly richer than stoichiometric, which helps prevent knock or pinging. The fuel is injected during the intake stroke. Direct injection may also be accompanied by other engine technologies such as variable valve timing and tuned multipath or variable length intake manifolds. Water injection, or more commonly exhaust gas recirculation (EGR), may help reduce the high nitrous oxide emissions which result from burning ultralean mixtures.